what I had mentioned was that I think it was a bit short, right? Like those who did it, the writing style was a bit short. The verb they use for these exams, for the written exam, the most common verb is the verb outline. And outline carries with it about three sentences, like three, I would say three sentences, maybe two sentences or three sentences. But outline is like three lines then, 3 to 4 lines. So if you write a point, even if they had said like identify the root cause of the accident, which is a possible question. And you say the root cause of the accident is management failure. No, that's just one line, right? So for like many of us here are the open book students. You all did the exam in the open book era anyway, which is still going on, right? But if you wonder, well, what else do you say? Because you don't have a case study, right? Remember, with these exams, it's just a flush question. So what else do you say? The answer is you can make up an example. You could actually make an example up, right? You can probably just say, for example, and that gives you the additional line that you say, for example, um, if like management failure is not identified and corrected, and you can give an example. You can say like management, like managers may have the opinion that the accident is the fault of the worker, right? But you make something up because the one line is not going to give you the mark anyway, right? So I have this syllabus up here. I don't know if can you all see it? Can you all see the syllabus? Yeah. Yes. 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 No. Yes. No.
Yes, sir.
Okay, good. Yeah, actually Wednesday, if you look at the first part of Wednesday recording, some like it wasn't shared for the students now. Like I could have seen it, but the students wasn't seeing it. And actually one brave student, which actually is a good friend of mine, he about 50 minutes in the class, he said, well, we don't see anything. But you should always say if you've seen it. Like once I start, there's always something in the background. If there is not, I will tell you. I will often say, look, I'm gonna stop this share. But if you never hear that, once I start, there's always something shared, right? So today we are on to 1.3 today. Again, I would want to, of course, congratulate all those who did the process safety course. I have some of you all here, and I think we got 89%, well, 90%, right? 89% passes. Two students did not pass the process safety, but the reason why I'm mentioning in the dot is because there are some common elements. And if you look at the syllabus, I was telling you all that last week, you see process safety up there, process safety leadership. So those who did the process safety course, just would have been a nice, like follow up then, right? Ideally, what it was, um, process safety was level 4 and oil and gas is level 5. So you see hydrocarbon process safety. So those who did the process course, of course, if you didn't, we would take it from scratch again. I'm just saying that those who did the process safety course, you would have seen, like for example, these things, levies and CVCs and UVCs, and even today's class. Today, to me, the whole class today is like a process safety lesson, right? And so that's good. And that those who would have done that course would have had a little foundation going on. And I mean, not to put down the process safety, but remember, process safety is multiple choice. So in a way, it didn't have to really work. Yeah, you had to study, right? But the answer was there. The answer was like right there. Is had to be one of the four answers because it's multiple choice. But the oil and gas is level 5. It's some of the same thing. Of course, there's some more things when it comes to oil and gas and stuff. But the lesson today, 1.3, is on risk management techniques, and that doesn't change. It doesn't even change for the degree. So it doesn't change, right? So 1.3, I don't know if we're going to get into 1.4. I didn't plan to. I did not plan to get into 1.4. The reason is that, well, unlike process safety, like if I'm teaching HAZOP, I have to make sure you all understand it because next thing they give you all want to do. But process safety, we'll just assume. Well, we didn't assume, but we kind of just said, well, you just had to know it as a multiple choice, but you're not really required to produce then or replicate a HAZOP or a bow tie. But in this course, you probably will have to because it's a written exam, right? So just to read it out here, I'm just going to touch a couple of them. Risk management techniques used in the oil and gas industries. The purpose and uses of risk assessment techniques, qualitative and quantitative techniques, and why they differ from the 5x5 approach. Well, from the five-step approach. And we will talk about that as well, right? How risk management tools are applied in process safety, risk identification, assessment, application in project phases for from concept design, and that like that's your HAZOP right there. When you say concept design, that's a HAZOP study, right? Startup, the concept of ALARP and the management of major incident risk. I don't know if you get into the concept of ALARP because the techniques themselves is kind of long, right? But Wednesday, of course. Industry-related process safety standards inherent, and you see process safety standards inherent safe and risk-based design concepts, engineering code and good practices. Well, I could think about the engineering code as being a hazard as well. The concept of hazard realization, for example, loss of containment, leading to ignition, leading to explosion fires, leading to damage, injury. The concept of risk control using the barrier model, and there are a couple of barrier models. One of them is actually the bow tie between hazard and hazard realization. Use of modeling such as thermal radiation output blast zones for risk identification. Now, it is actually in the handout I sent to you. I did send you a handout, right? As hopefully I didn't forget. Did I send you a handout? Second handout? I wonder if I did. Do you all have this? Do you have the second PowerPoint?
Yes, so you sent it.
I think so, yeah, as normally market. So there's a pull in the register. I know I sent it. If I had forgotten, you'd have gotten it today, right? Well, your textbooks came as I mean, I wouldn't say as promised because Mama tell I'm not DHL, but predictably, uh, I got uh, I got some blues because not from you, because I contacted the shipper and told them the books didn't arrive yet, and then they said, well, it's not 10 working days as yet, right? But that's what sometimes we have to do. And your books came at the office. I have one here. I think yesterday a couple of you all came by and collected. They're still there for collection. The book is yours. Remember, that's the thing with me. I tried to give you original textbooks. I don't give anybody any copy books. I don't hide any cost until it have a next cost. No, the cost of the book and everything included in the price, right? So, as I know many of you don't have it, I probably wouldn't use too much of it, but I would use it. I would use it if you have your book, I would use it, right? So I could shout out some pages, I'll show some pictures. You'll soon realize though is that it's the same thing in the PowerPoint, but I kind of wanted you to see that for yourself, right? So we are in trying to find the page in the textbook, right? We are in if you have it, those of us who have it, we are in page 18. Risk management techniques using the oil and gas field. Let me just share the PowerPoint with you all. It's the same thing. Um, and like I said, I would have to, explain the techniques in such a way that you all kind of understand it because unlike the PSM exam, which is multiple choice, those of us in the book, you'll see if you have a book page 18, and I just kind of go down here for those of us who don't, you'd see the risk matrix, same thing. Those of us in the books, you see the same risk matrix. Many of you may be familiar with that kind of matrix anyway. But to the top of if we go back, should we go forward or go back? To the top of even page 25, you'll see HAZOP. Look, I have HAZOP here, a HAZOP study, right? But this takes some time to explain. It's not to read, you see, page 25, because unlike the process exam, where they just ask what is the meaning of the term HAZOP? But you may actually have to do one now, right? So HAZOP is there. Right? One of the main ones is your HAZOP. They even have HAZIDs, FMEA. HAZIDs is on here too. Look at right there. HAZIDs, right? HAZIDs is right there. So let's make a go at it. Those of us in the book, I just wanted to shout it out to you. If we can find your page 25. HAZIDs is there. FMEA is there, right? What again? I'm sure I'm seeing hazard realization. So definitely that's the bow tie. This is from your textbook, and this is mine on this slide. Right? So it's the same thing, right? So that's gonna make us start. But if you came from level 3, and you did not do the level four, like I said, you have to learn from scratch today, right? And so there are even some people who did not even do the level three. So that's why it's not just a read nice to explain, because remember, you have to kind of explain this to yourself and write it out for yourself anyway, right? So that's why I said I don't think we'll reach ALARP as low as is reasonably practical. But it's right here. Now that you have this slide, maybe you could read it out, right? But I don't look the ALARP slide 50, right? I don't think we read slide 50 because it's not a reading exercise. You see, it is what it is. It is a learning exercise, right? So going all the way back to the top, again, welcome in from those who are here, level three students, level four students. Let's have a go, right? So risk management techniques using the oil and gas industry. The first part will go kind of fast because it's just to read, right? So the main objectives or objective of risk assessments is to determine the measures required by the organization to comply with relevant health and safety legislation and thereby reduce the level of occupational injuries and ill health. Its purpose is to help the employer or self-employed persons to determine the measures required. This is risk management, right? The measures required to comply with the Management of Health and Safety at Work Regulations 1999, Regulations 3. I may have to explain that because, well, the thing to say, and again, hopefully you all take notes. Today's such a hot day. I have the fan and the AC on. Actually, I take off the fan because it's making me cough. But yeah, I mean, those of us who may be looking at this, I think Trinidad today is very, very hot, right? Temperature, getting up there to the 40s anyway, right? Um, yeah, so for those who don't know, right, the UK have many laws, and this down here, this is one of the laws in the UK. So I'll say it again, it's called the Management of Health and Safety at Work Regulations 1999, and you may want to kind of commit that to memory because it's not a multiple choice exam. There's an acronym for it. I'll write it here for you. So the Management of Health and Safety at Work Regulations 1999. You may want to kind of learn that phrase. You see why? You see what happened today? Today the topic is risk management techniques. But what what you have to pick up if you read this is that what the law is actually telling you to manage your risk, right? So risk management techniques, if you read this over again, its purpose is to help the employer or self-employed persons to comply, right? So why do all of these techniques we're going to learn just now, HAZOPs and HAZIDs? Are those of us who did processes like a refresher, but you have to probably learn it a bit different now, right? But why bother do that? It's not just good management. The heading is risk management, but there is a law in England, right, that actually says that. So if you do manage your risk, you are compliant with the law, and in particular, Regulations 3. Regulations 3. Now, in the UK, um, like a part of a law, you know how we would say sections, like we would say section 2, but for regulations, a part of a regulation is also called regulations. So that's kind of strange, right? So when you see regulations 3 of the Management of Health and Safety at Work Regulations 1999, this means that this is like a section in that law. Then it doesn't mean a separate regulation. It's like a section of the regulation. But as I said, the terms is a bit funny. They say regulations of a regulation, not part of a regulation, right? Anyway, Regulations 3 is what requires a risk assessment. I'm going to put out here RA, and in a way, that's like what we're doing today. It, in fact, doesn't just require a risk assessment, but it requires what is called a suitable and sufficient risk assessment. As I mentioned this, right, let me just say this again for those who came in a bit late. Having spent all the monies you all paid us, your first payment normally go to NEBOSH or books and stuff, right? Please come and collect your books, right? Those of us who have their payments up to date and stuff. The worst thing is having spent $20,000 in books and then the books remain there and then yours in the course and and you're collecting your book, right? So please do that. Just make arrangement with me sometime in the week. Um, the following week, right? The first week of October, I'm actually not in Trinidad. I think that's going to affect our class as well, right? I'm actually in Guyana on the 3rd of October, not next week. So next week I'll tell you what Sunday, actually Saturday and Sunday, right? I believe the company want training on a Sunday, so I think I'll be training on. I don't know if I'm going to get half day off. As far as I know, the training goes for 5 days, and the 5 days go through the weekend. So I don't think I have the Saturday nor the Sunday off for those who are in my Saturday classes as well. But that's not next week. Next week is normal, right? The Wednesday too. The day I'm leaving is Wednesday, the 3rd of October. So that's the day we have classes in the evening. So I'll probably have to change it a bit. Um, but I have to let you know because I'm not quite sure what time I'm actually finished. Like if I'm training in a company, I'm not too sure what time I'm finished. What time would I get back to the hotel? Our classes start at 6. Would I be able to make it back for 6? So these are the things I'm unsure about at the moment, right? Keep that to the back of your mind. And that would affect us for 1 week anyway. Just keep those things to the back of your mind, right? And those who know me, you know that that happens all the time for the last 5 years. I come and I go. Wherever there's work, I go, right? That's just how it is, right? Take this down, anybody. Anybody not taking it down? I want to erase it and move on to the next slide. Let me see if I can move on. Sometime it doesn't allow us to. All right, well, I was able to, right? So risk management techniques using the oil and gas industries again. So to determine the measures required by the organization to comply with relevant health and safety legislation, we kind of just said that risk management techniques are there to ensure the risk is acceptable or low. It fulfills a moral duty of care to employees to show them that you're caring about them in some way, right? They are called risk management techniques. If a hazard is analyzed and the risk of it is reduced, you would have a safer workplace, reduce accidents, etc. And if you reduce accidents, but then you reduce the direct and the indirect costs associated with an accident, right? So again, here comes the tricky part that you're going to have to be familiar with that, right? Unlike, and this is so, like it's kind of like a re-paradigm shift, which I don't think that's a word, right? But a paradigm shift is a shift from the normal, but did this shift is going back to how exam was before the pandemic, where you had to learn that, right? So that's a nice question. Of course, with the current type of exam, it's like a 4 mark. Somebody was outside. Did I admit them? Jeez, I did think I got it now, right? Yeah. So like with these exams, you had to be familiar with your notes, right? What we used to do, we used to print the notes. Well, I mean, students then print the notes and carry it with you. A lot of people, if you have your books, great. Um, I often felt once I realized the notes was the book and the book was the notes, I often printed my notes. I sometimes still do. And like wherever I'm at, I'm at the bank waiting in a line. I don't mind because I have my notes I could read. I'm at waiting to pick up someone, the person taking long. I will still read my notes, right? So printing the notes is a good thing. I don't know if you all know how to do it. You can print like 6 slides on a page, so you save paper. All of this may take you about 10 pages. 6 by 10, 16. It may take you about 11 pages, 12 pages, because it's 70 something slides, right? But the thing is, you have it, and if you have it, you can. I don't ever do this one, but that's what I used to do. I used to be driving. And I'm not looking at it while I'm driving. But if there's a traffic light, there's a long thing on traffic, I'll have it just on the seat there. I'm not really looking at it. But I can still try to see what's it all about. And again, back in my day, it never had what you all have. You all have the video. So, I had a student in the process class just yesterday. He came and collected his cert. He got the highest 90 something, like 90 whatever, right? And he was telling me, he said, he said, Sam, he just say Sam, right? He said, Sam, you know what I do? I put on your stuff like YouTube and Shadrach Safety Institute. Like if he's not looking at something on YouTube, he's looking back at it. He told me yesterday he's not in this class, right? He told me yesterday, I am listening to your oil and gas videos. Remember they free on YouTube? He said he listened to one, right? I said, well, you must have really some sleeping kind of disorder because to be listening to me for so long and not falling asleep, something is weird. But I just showing you how everybody different and everybody, know what they want, right? But you all have that. My lecturer too, back in the day, of course, we didn't have these things, but that's a telling like my lecturer had told me at one point in time, I was so busy, like my lecturer had said, why not take off the radio in the car or the music, whatever, right? And I said, wow, that's really a good idea because I can take off the radio and actually think about some work while I was driving. Not all the time, right? I play a like lots of music, which is why he told me to take off the music, right? If you understand that part of the story. But the only thing is find some way to study. So that's what I'm trying to say. Download the video, whatever. If you have, you're stuck in traffic, you could, I guess you could listen to it because you all have that sort of access now that we didn't have, before the pandemic anyway, right? All right, the purpose of a risk assessment. A risk assessment is the process to evaluate the risk arising from a hazard, identifying preventative and protective measures, taking account of the adequacy of existing controls, and deciding whether or not the risk is acceptable. Risk assessment is an analytical process that identifies hazards, who might be harmed, and in what way they may be harmed. The purpose and use of a risk assessment is the heading again. In the UK, the Health and Safety Executive, for anybody very new here, the Health and Safety Executive is OSHA, but they don't say OSHA in England. They say the HSE, right? So if you don't know that, just take a note of that. Wherever you see HSE, it doesn't really mean health, safety, and the environment in England. What it means is the health and safety executive, and they are the main health and safety, or the main government health and safety body in the UK, right? So the UK Health and Safety Executive in their publication, yes, they produce books. Five Steps to Risk Assessment. The name of the book, this is the code for the book, INDG 163, states that risk assessment is a careful examination of what in your work could cause harm to people, so that you can weigh up whether you have taken enough precautions, or you should, do more to prevent harm. And in most cases, you have to do more because no risk assessment is perfect, right? The five steps coming out of INDG are these steps. I would ask you all to learn them, those who don't know them as yet. The five steps are, I think I was telling you all, they have some nice ways to remember this. Anyway, I'll say them anyway. Identify the hazard, decide who might be harmed and how, evaluate the risk and decide on precautions, record your findings, review your risk assessment if necessary. Because it's a written exam, I would say no, I don't see this question coming because this is actually level 3 right now, right? And so to get into the oil and gas level, they'll ask you one of the oil and gas risk assessments there, like one of those methods. This is like a normal risk assessment model, right? So how this is normally done, it's normally done on a table. You'll probably see one. Yeah, it's normally done like on a table, but not like that. That's just a matrix anyway, right? But it's normally done like on a table, and then these words here become the column of the table. So the first column is identify the hazard. The second column is decide who could be harmed and how. Third column and stuff is evaluate the risk. And then what the document itself becomes a record. And then a risk assessment is reviewed every year. It's reviewed annually. In fact, the UK just said regularly, but most countries do it annually, right? So you review risk assessment on a yearly basis. So for risk assessment, so for the oil and gas, or for the oil and gas industry, where the risks are more complex, techniques are likely to require more depth and technical insight. The UK Offshore Safety Case Regulation 2005, which is another law, require, amongst other matters, a demonstration that all hazards with the potential to cause a major accident have been identified, all major accident risks have been evaluated, measures have been taken or will be taken to control major accident risks to ensure compliance with relevant statutory provision, right? So they are this is actually straight from your book again. I don't want to go into it, but those of us in the book, just check around page 24, 25, you see the same thing. So you have types of risk assessment. Here, what do you want me to read or just explain? I feel I'll just explain it, right? But I wouldn't be writing out the whole video. It'll take some time, right? So there are about three main types of risk assessments. We have what is called a qualitative risk assessment. I'll just put Q here, but all of them is Q. So I don't know how you're going to differentiate them, right? So a qualitative risk assessment is one that uses words, right? So like when you assess the risk in a qualitative risk assessment, you are saying words, like you're saying the word is high, you're saying the risk is high, the risk is medium, or the risk is low. A qualitative risk assessment uses words, right? The other one, a semi-quantitative risk assessment, uses words and numbers. A semi-quantitative risk assessment. In that case, actually what they do, they measure risk on a scale of 1 to 25. Yes, this is universal. This is not something made up. This is the universal risk matrix. If I free up my two hands, I will show you the one in the book, right? You see the same colorful thing in the book. You see the risk matrix goes up to 25, right? So it doesn't really cross 25. That's just the standard anyway. It's measured from 1 to 25. You can't miss it. Check it out and see, right? And those of us who did laboratory, you probably know this already. You see, like the highest number is not 100. The highest number is 25, right? So risk is measured from 1 to 25 using the semi-quantitative method. The numbers that are higher to 25, if you notice, is red. And of course, in the middle can be yellow. So the lower numbers are actually green, right? So if you do a risk assessment and you come up with a number, I'll show you how to get a number in a bit. You come up with a number like 20, well, then you could say the risk is 20 out of 25. So you notice semi-quantitative using numbers, but then the number have a meaning. 20 out of 25 is going to be high. So in a way, you use a number and you use a word, which is high. Like 25 out of 25 will be very high, right? 1 or 2 out of 25, they say, let's say somebody say 1 by 1, right? But I guess for those who know the matrix, right? 1 over 25, but this is the number, the risk associated is 1, and 1 is seen to be low. So in the semi-quantitative method, they're using numbers and they're using words, right? The last method, I have number 3 up there, so I probably have to move from there. So the last method is something called a quantitative risk assessment. You can probably figure that one out, right? Qualitative. Then you have semi-quantitative, and the last one is quantitative. QUAN, right? So a quantitative risk assessment is one that actually just uses, the best way to think of it is pure maths. The best way to think of it is pure maths. What do we mean by pure maths? Another way of thinking about it is binary. In a quantitative risk assessment, they use numbers between 0 to 1, right? They use numbers between 0 to 1. So the next question is, are there numbers between 0 to 1? Of course. Endless, in fact, infinity, right? So 0.2. So in a quantitative risk assessment, the number you may come up with may be 0.86. Yeah, maybe 0.86. So it's a little different and it really don't have a meaning. It is really just a number, right? What it does represent, it represents a probability of the event happening, but it doesn't represent high, medium, low. So if you notice with the quantitative risk assessment, you're not saying, okay, I didn't put high with that. I didn't put low, I didn't put medium because it doesn't really carry a word meaning. What it represents is how likely it is an accident will happen, like 0.86. There's actually a way to convert it, which is beyond this class. But beyond now, we may get to it in another class, right? There's a way to convert that if you turn the decimal into a whole number, and you would see how likely it is you can have an accident. But it doesn't really represent high, medium, low. So that's why quantitative is said to be pure maths. It's just numbers alone, binary logic, they call it. Zeros and ones, like the movie Matrix. If you remember the movie Matrix, when the movie Matrix started, you see, of course, a series of zeros and ones. Yeah, so there is a whole set of numbers between 0 and 1, right? From all the decimal points, right? So those are the 3 types of risk assessment. Before I leave this though, because I didn't read the slide, I explained it, which is a way to go a bit faster, right? So you could have a read of it, of course, on your own, right? Before we leave it, we have to say that in the oil and gas industry, like they go from being subjective to being objective, if you look at the slide. So like if you go from qualitative is like a very subjective risk assessment. Like when somebody's saying the risk of a fire from an oil spill is high, but that's kind of subjective, right? It might be subjective if it's a big oil spill, but the thing is, it's a bit subjective there. It isn't as accurate as a number. If you say, okay, the risk is 20, 20 is better than saying high. Because when you say how high, when you said it was high, what were you thinking about? Was it 16? Was it 20? Like, what do you really mean by high? So if you go with the qualitative method, it's always subjective. And what you say because of that, the more hazardous the work is, then you need a better means of calculating it. So they say here, quantifiable risk assessments, like the one that uses numbers, are always more objective, better than. You can get a computer modeling calculations and stuff to calculate the exact figure. How do you think they get that figure 0.86? Exactly like, machines, calculators, computers that actually do that anyway, right? So these approaches to risk assessment reflect a range of detail ranging from the least detailed one or the least proven one to the best one, which is the quantitative risk assessment, right? So keep that to the back of your mind. I have seen, and you will see too, I'm just trying to finish this. Okay, so the choice of approach will take into account the following dimension, the level of risk. So the higher the risk, you need a better technique. The more complex the problem, you need a better technique. The level of detail should reflect or should be proportionate to the level of risk. So if the risk level was low, but in the oil and gas industry, it wouldn't be low. But if the risk was low, well, then you could get it with, you could get away using high, medium, low. But if the risk is high, you really need a better technique, right? I was saying, just trying to see how fast the flip between slides, right? It's like there is a past paper, I have it here for you. I could show you just now. They did ask a question on qualitative and quantitative. But let me finish off these here, and I would probably kind of reflect on it a bit because like to go back and forth is a bit of a stretch at the moment, right? So if we continue with this, we are looking at now some of the advanced techniques, right? If you look at this slide, like they're not saying risk assessment anymore, right? They're talking about hazards, HAZOPs. So those are the advanced techniques. But if you look at the heading, see if you can figure what's happening. Advanced does not mean quantitative. An advanced technique doesn't mean it's automatically a technique that uses numbers. An advanced technique, I'll say it again, please write it down, doesn't automatically means it's using numbers. Look, the book have HAZOPs here. But if you look at these things here, you realize that, well, I don't know if you can see it, but it's actually words. It's an advanced technique, no flow. No flow is not a number, no flow is a word, but two words. So advanced doesn't always mean it's the best. It's better than the normal array, but it's not the best of the best. Watch the next slide. The next slide actually does say there are some advanced techniques that are quantitative, right? There are some advanced techniques that are quantitative. We have fault tree analysis, hazard analysis, event tree analysis. The advantage of these, so these are the best of the best then, right? Your normal risk matrix, that's for level 3. That's everyday safety, right? Oil and gas industry, because the risk may be higher, you may need to use an advanced technique. But you have advanced qualitative and you have advanced quantitative. So in the best of the best, the quantitative is the better technique, even though both of these techniques here, or both of the heading, because look at my techniques it have here. Both of these groupings then, qualitative and quantitative, both of these groupings have different examples, but the best of the best would be the quantitative risk assessment, right? I don't think you'll get a full FTA to do. A full FTA is real stress. You could probably get a partial ETA to do. I don't know if we reach all of that today, right? ETAs are pretty simple. ETAs are real simple. It's like a family tree, right? I can show you a piece of it, right? I'll show you a piece of it anyway. So if I go on again, this is the normal approach or risk assessment. You say what can go wrong, how likely a hazard could be realized, what's the consequences of it. You multiply these here and you get the risk assessment. If the risk assessment number is high, you put measures in place to reduce it, right? And for those who don't know what I mean by that, but there's a formula, right? When you see here, risk assessment, there's a formula you have to use. The formula is likelihood by consequences. If you watch here, you'll see likelihood and consequences. So these are really two things to multiply. They'll have a number here and a number here. Actually, you actually choose a number, like how likely an accident would happen, and you will choose a number like 3, and how bad it could be like 5. And then, well, to get the risk, you multiply those two, right? So 3 by 5 will give you 15. This is the old risk assessment. This is 15 over 25. So if you look on the book or the matrix, 25 may be somewhere in the, what 25 is? Sorry, 15 my mistake, right? 15 kind of getting in the red-ish, right? Meaning that this is kind of high risk, right? So you can probably still say high risk. 15 out of 25 is kind of high risk. If you had to draw it on a number line, 15 is closer to 25 because, like half of 25 is 12.5, right? So I guess in a way, 15 is classed as high risk, right? So this is what we mean by a risk assessment. I'm going to have to take it off though. Um, right, taking that off. Right. So as I was saying, there's a formula for it, and then we use numbers and stuff. We use numbers. Well, I think that was laboratory, right? But I don't know if you wanted me to show it out again. They use numbers like 1 to 5. So as I said, the likely could have been 3, and the consequences could have been 5. But you pick your numbers, how likely something would happen, and then you multiply it and you get a reading out of 25, right? But to get in the advanced techniques, I don't know if you want us to go straight to the HAZOP. I think we can do that. We can just go straight to the HAZOP if you want. And let's introduce it a bit here, right? Well, all of this is the introduction to it, right? So I could take it from here. Oh no, let me just take it back. I saw hazard realization in your syllabus, right? And so there is a theory for this. The man that came up with this, his name is actually Reason. Yeah, his name is actually Reason, Reason, and he produced something called the Swiss cheese model. The idea behind this is that for an accident to happen, a lot of things have to go wrong at the same time. You know, a lot of things have to go wrong at the same time. If we look at it here, we see here eye injury. The person was not wearing eye protection. At the same time, they were poor fitted eye protection provided to them. Management didn't do any training. There was no written procedure on using the eye protection. And I guess the person was working with corrosive chemicals, right? Now, again, that could still go on and there'll be no accident. That doesn't mean you'll get, like chemicals in your eye. People sometimes work with chemicals all the time without gloves, without eye protection. But if I guess the person, you see, human behavior here was probably, not being careful and some of it spill or splash. That could be the reason, right? So a lot of things have to go wrong this at the same time. And of course, in the UK, they have these, you have the pepper jack cheese and stuff that I suppose he would have drawn this model over where the hole in the cheese then represent like something would have failed and like the worker wasn't using his, goggles at the same time. Probably nobody was supervising at the same time, it wasn't fitting properly at the same time. Maybe he used like an inappropriate container in decanting it. Maybe he didn't have a glove, and that's when some went on his hand and he probably put his hand up in the air and some went in his eye, right? So a lot of things then, like have you all seen that movie, Final Destination? Have you all seen the movie Final Destination? Yeah? You know the movie Final Destination, right? You all still out there? I don't turn any cameras off.
Yeah. We saw it.
If you see the
Good
movie
movie.
Final Destination, you see, I mean, a lot of random things happen, like water will fall and get by a fan, and then the fan plug drop on the ground, and then somebody step on it at the same time. So, that's the idea here. Like an accident will only happen if all we refer to these as barriers, because if the cheese slice had turned a bit, like the person, okay, like the person not wearing the safety glasses or goggles, right? If this one right here was a supervisor, notice that the accident would have been it would have been prevented then, right? If a supervisor was and say, okay, well, Frank, where's your glasses? Put on your glasses, but then the whole thing would have been prevented, right? If somewhere here they say no training or there was a written procedure, and let's say there wasn't a supervisor, but the workers was looking at the procedure and the procedure said you must wear safety glasses, you must wear, nitrile gloves. right? Use the appropriate container with a closing lid. If they had done that, then it wouldn't happen. So they refer to these as barriers. They, like the other part of the slice that doesn't have a hole in it is referred to as the barriers. If you reproduce and you see barrier anyway, it's kind of like supervision, training, instruction, good housekeeping, good containers. And if those things were in place, then you wouldn't have the accident. But for the accident to happen, everything have to go wrong the same time now, right? So if measures are put in place by management, systems, information, instruction, training, and supervision, safe systems of work, safe tools and equipment, safe work environment, then accidents should be prevented. Theoretically, the more barriers are in place, then the less likely that they will fail, right? Simultaneously, however, sometimes a systemic issue would affect all barriers, thereby rendering them all ineffective. For example, a general lack of adherence to safety procedures resulting in a vessel headspace being ruptured could undermine many other barriers. So there's like a tank example, like something happened in a tank and yeah, you probably had other barriers. The other barriers would have been okay, they work a train, but what if you have a fire, a massive tank fire, right? Or you have a bond. But how much the bond go hold if you have a fire? Bond can't do nothing for a fire. So sometimes if these things go kind of haywire in the oil and gas industry, ninth one, barrier, because of the failure of one barrier then, barrier, the failure to have a proper permit to work, it resulted in a lot of other things escalating then. The lack of isolation. All of those things are barriers that should have prevented that accident with the divers. But when you open an isolation valve, which is not supposed to, that's why it's called isolate. But those of us who know, and a permit to work, right? Isolation means lock off and prevent it from being turned back on. Lock off, and so it doesn't mean enough isolation. It just doesn't mean lock off alone. It means prevent from being turned back on. So how could somebody put on the adjacent valve to create the suction in the line, right? So sometimes when things go wrong, it doesn't matter how trained you, how much years experience you have, how much air tank you have, the whole damn thing goes down there because of that failure anyway, right? All right, let's go to this one is setting up the idea of the HAZOP. So I'll read out these two here. So risk management tools, HAZOP is probably, I think, one of the main ones. I do want to finish that one and probably one other one today, right? So these refer to the approaches used to predict and prevent risk from being realized. Most are very accurate, notwithstanding human limitations, errors, and violations, and can provide a means of intervening in the process, either in the design or modification stage, and that was on the syllabus, right? As well as process stages to control the hazard realization. They, however, require a greater deal of technical skill and competence than your normal RE, and we're going to do one just now, right? I think this is straight from your syllabus, right? Project phases and suitable risk management method tools. They talk about, like what technique should be used in the concept, the design, the concept selection stage. Like what concept, when I say what technique to analyze the risk. So are we going to use the 5x5 matrix to analyze the risk in the design stage? We could, right? Are we going to use some of the other words you saw, like the ETA in the design stage? So this is what they're trying to say. There are different techniques then, right? Project phases and suitable risk management methods. So which method aligns itself to the different stages of the project, right? So, off the top, I'll tell you, HAZOP is design, right? Project planning might not be HAZOP. Detail engineering, construction, probably a normal risk assessment, turnover and startup commissioning, that could be a HAZOP too. Operation and review, modification is a HAZOP. Decommissioning can probably be something like a ETA, right? I don't think they're going to ask you to match up these things. The point I was trying to suggest here is that we are looking at advanced techniques, and the advanced techniques can be suitable for different phases of your project, at least as you're heading on the syllabus, right? So different techniques then would be best at certain stages of a project. So the best one I tell you, or at least the one to start with, is something called the HAZOP. I'll read and I will stop reading and I'll explain as well, right? But I want to read one or two slides. So first used by the Imperial Chemical Industry Company in 1960s, a hazard and operability study is a structured and systematic examination of a planned or existing process or operation in order to identify and evaluate problems that may represent risk to personnel or equipment or prevent efficient operation. It will identify deviation from the design intent. Watch it up there, design, right? I mean, it's not multiple choice. That sounds like a multiple choice question to me. Which technique is best at the design stage? But is really a hazard. But again, because you all have like short answers, 4 marks, 5 marks, 6 marks, next thing I don't see that because you see they could answer something better on the hazard. It have better things to ask, you know. It have better things to ask, right? But in the very beginning stages, um, if they were setting up a question and they say, well, discuss two techniques that can be used during the phases of a project, and they give you A, design, B, decommissioning. Well, then that's a kind of tricky question if you don't know the word. But from now, I will tell you what they're asking you to talk about is HAZOP and then probably ETAs or FTAs in the latter stage. You can probably write that down. I did say try to have a book with you. We will try to reflect on our passive just now, right? Just trying to finish it before we go there, right? Okay. So, in a hazard, a team of experts from various disciplines are involved. I'm going to read about 3 slides and then stop and explain, right? However, a team leader is usually chosen. It is best used at the design stage in a process, but can be used for plan modification. And as if you go back here, when we read modification, I said HAZOP again. You see it? I said HAZOP in design, and I say HAZOP in modification. I don't think they'll ask the same thing twice. They may just say, which technique may be used in the design or modification stage, right? So team members can include a secretary, which is a scribe. You see why you need a scribe just now, right? Design engineers, mechanical engineers, electrical instrument engineers, operation representatives, process engineers, safety specialists, right? So risk management tools has a procedure. So the scope must be defined, such as the part of the process plant operation that will be studied. A parameter or the parameter must be chosen. Process parameters can include flow. So this is what they're looking to examine, right? Like what's the flow rate of the pipe or the tank, pressure. Yeah, they pick what they want to study, right? Temperature, level of liquid, viscosity, composition, pH. For example, if you choose temperature of sulfuric acid in a pipe is more than 20 degrees Celsius, right? So that if you choose temperature, temperature is said to be what you're studying. And what you're studying is called a parameter. I'll kind of make some sense of this in a bit, right? In a HAZOP, they use codes. I think I saw that in your syllabus. They use something called a code or a guide. Word must be chosen. If you go back to the slide that talked about 1960, this was, I mean, it wasn't the time of the war, right? War. I mean, are we in Ukraine, Russia, and different parts of the world have war, right? But this was actually the time of like the Vietnam War, right? World War II had ended and stuff. But the thing is, the technique was synonymous with weapons and stuff like that then, right? I don't know if you know that. HAZOPs are used in like when they're looking at doing it like a drone strike, a missile strike. So that again, HAZOPs are used by the army, by the military, like to assess the risk then of a drone strike, right? So because of that, initially HAZOPs were not part of safety. There was like a military kind of thing, NASA kind of thing, right? But because of that, then they were accustomed using codes and like when you say Roger, and of course in the war and stuff, they use different codes, but I can't remember any now because but I mean if you look at television shows, you probably see some of them, right? If they say, like the eagle has landed. The eagle has landed. So that's a code. But in terms of safety, the codes go like this then. Some simple code words are no, more, less, as well as part of, reverse, other than. Now, the thing about a code, right? The thing about a code is this. See if you can listen, right? As how I said, right? The people who know the code, they know what it means now. Like when you say the eagle has landed, right? I actually don't know what that means. I suppose it probably means somebody read somewhere, right? But In the team now, if you go back to the side, so there's a team of people, and the team, if you wonder what the leader does, the leader picks the code, right? Like what we're going to study. So now it's easier than you think. It's not the army. Forget that if you want to forget that. Just draw an illustration to where HAZOPs came from, right? It's easier than that. All it is, right, is like if the team say we're going to study temperature, if they want to study temperature increase, if you watch, what they will do, they will say the word more. You see it here? It's more than 20 degrees. So it's instead of saying increase, the word that goes on the HAZOP, remember there's a risk assessment, is the word more. And when the team hear more, the team will consider, well, what if the temperature does go up to more than 20 degrees Celsius, right? Another very simple word is the code word is the word less. So less means a decrease. Same thing with flow. If you're looking at flow of whatever, gas in a line, water in a line, oil in a line, you say more. What if the pressure increases more than, the PSI of that particular vessel then? Could it withstand it? Now, remember, a HAZOP is a risk assessment. Try to answer what it is I said in there. No disaster has happened as yet because we said the HAZOP could be used in what stage again? Anybody remember? What stage is a HAZOP used in a process? Is this when the accident has happened?
Nah, in the design stage.
In the design. So, like a risk assessment, when you say the risk of somebody slipping and falling, and you say, okay, 3 by 3, 9, right? Remember, nobody didn't fall in that. You just saying, well, what if somebody fall, right? In a risk assessment could be thought of as a what if analysis. What if, right? What if we have, the worker lifting the heavy boxes suffer back pain, right? But you're saying, okay, 3 by 5, 15. But the thing is, the worker didn't suffer the back pain. So that's why a HAZOP, remember, if you look at the heading, folks, remember, it's advanced RAs. It's advanced. But the principle remains the same. I'll say it again. A risk assessment is predictive. No harm has actually really happened. 3 by 3, 9 for the person slipping and falling, but the person didn't fall. It's just predictive, right? So in a way too, when the team says more, temperature goes up, less, temperature goes down. Well, what happens to the vessel? Does it really erupt? No, it doesn't. It's just a risk assessment. Remember, this is done to identify the hazards so that we can prevent the real harm from happening, right? So what I would advise here though, I would advise you to learn 2 guide words. You could just go with more and less. The others have meaning. I think they give it the meaning in the textbook, right? But yeah, they actually give it the meaning in the textbook, page 25. More, a quantitative increase. I think I have it here too, So like I said, book thing is the same thing, more. Same thing in the book. I read from the book just now, more, quantitative increase, less, quantitative decrease. I don't know if you could see it. See it? So you're missing nothing. Those of us who don't have your book, stop making excuse. Learn the thing on the slide. Right? Some people say, well, I ain't got my book yet. Well, learn it on the slide. It's the same thing, right? So like for an 8-mark question, and I don't see the action here 8, I see the action here 6. Because you see, they could ask you something as that to get an extra 2 marks, right? So they could ask you to do like a simple hazard calculation. I'll show you one now. But they can ask you something as then, okay, like at what stage of the process phase is this technique best used for? Identify 2 for 2 marks to give it the 8 marks. The 6 marks for actually doing the HAZOP. And maybe 2 marks to saying what stage is design and modification. Right? So they try to spread out the marks then. I don't see the actually 8 marks on just one HAZOP alone. I can see 6 and 2, something like that, right? But the other code have meaning too. Like for example, reverse is the logical opposite of intent. So that happens, something that's called backflow. So, for those of us in the business, you're on a line, a oil line or whatever, right? And you're getting backflow, you're getting back pressure, right? In reality, though, I mean, that's actually real. But if the team was to consider, well, what if we have backflow? What if the valve fails, right? And then, because those things happen, you have mechanical failure. So what if we have water coming back into the the silo, or water coming back into the vessel. Water, you may think, is not hazardous, but it is, right? Water mixed with hydrogen or catalyst could cause an explosion because it produces hydrogen gas, right? So you consider what if then, right? And you could probably consider reverse, but I don't see the asking you more than two guide words, and that's why I just suggest more and less. Those are the two easy ones I can actually show you in the book, right? So commit two guide words to memory. So now comes the main thing. Yeah, that wasn't the main thing. What you need to understand so far, HAZOPs is a team-based approach. They use words. It's qualitative, but it's a good technique. It's an advanced technique. A team of persons will do it, and they normally will pick what code they want to look at. They'll pick what code they want to look at, and they'll pick what they want to look at. If it's temperature, pressure, corrosion, flow, right? Whatever, the chance of an oil spill, whatever you want to pick, that's called the parameter. But well-known parameters are what you're seeing here now, like temperature is a nice one. So if they ask you to discuss a hazard, because just pick temperature, I'll just pick the one I have here. Temperature is supposed to be 20 in the manufacture of soft drinks. Wherever you have a soft drink factory, Guyana or Trinidad. So what if the temperature goes above 20? Would the soft drink still be good enough? Would the beer still be good enough? The answer for that is no. But other than the product being wasted, like, I mean, and product wastage is part of a hazard. Like, that means that whole batch of, acid, water, ingredients have to be dumped because nobody will want to drink it. They will say, okay, look, this thing tasting bad, right? This orchard juice, for those of us in Trinidad or Caribbean, cool or whatever, right? It not tasting how it is. It's bad. And of course, the company would not allow that. They wouldn't allow a defective product to leave their supply. Because once the reputation goes out there that, look, orchard stuff too acidic or whatever have you, then nobody will want to buy it. You have that population, kind of outcry. So the thing is, outcome of that is like product wastage in like in the manufacturing industry for something as simple as the temperature going above 20 degrees Celsius. If it was meant to be at 20, it can't be more, it can't be less, right? All right, so what I was saying, here comes the main thing. The main thing is that a hazard have a format. So I need you to write it out for me, right? What I did here, I put the acronym here. I'm going to write it out for you. I put the acronym here. GDPCE, right, is the acronym. And what those things represent, they represent the heading on the table. Remember, HAZOP is a risk assessment. Let's grab a marker. HAZOP is a risk assessment. So it's going to have a table format then, right? Looking at the space I have, I wouldn't be able to fit all of it here, but I'll start to. If you have some space, you can fit them out, right? Or maybe I want to fit it horizontal because it's meant to be horizontal. Maybe I could start up here, right? So the G stands for, you can figure that one out. The G stands for the guide word, which is the code that you're using, right? I'll just put guide, right? The G stands for the guide words. And a hazard table, in a normal risk assessment, you're supposed to start with the hazard, but here you're starting with the guide word. So let's just say more. I'll just put, when I could write another one, more, right? I'll say it again. In a normal risk assessment, you start with the hazard, but not the hazard. You start with the guide word, right? The other word here is the D stands for deviation. Deviation. Now, if you only remember these things alone, it's a lot of maths. To remember the format alone, if you say, like this itself could be like a 5-mark question. They say, what's the format for a hazard? Right? They say outline the format. And of course, you have to probably outline it. Outline mean you're not going to say guide word alone. You say the format for hazard includes analyzing guide words, comma, such as the team of specialists can choose words such as more, meaning an increase in, and you can pick something to talk about temperature pressure, or less, a decrease in temperature pressure. And that's a full sentence on guide words. You understand that, folks? Yeah, tell me if you understand it, I'll be telling you, right? So deviation is, well, the deviation from the design intent, right? So a deviation is from the intent. So you'd have to make up an intent. If they ask you to discuss it, you'll have to say, like, for example, the temperature should be 20 degrees Celsius. But when we say more now, it means the temperature is going. So deviation means it's going higher or lower than the design intent. Maybe I could put the word design up here too. And you can give an example. You can say in the beer industry, in the Coca-Cola industry, the soft drink industry, temperature of soft drink should be at 20 degrees Celsius. An increase in temperature then will reflect a design deviation. And that's it. That's how you explain it for like 2 sentences, right? The next thing here, if you have any questions, please could you all unmute your mic and ask me. I've seen some stuff in the, remember it's only 2 hands I have, right? And so like both hands to write on Zoom, right? I wouldn't be able, if you just unmute the mic and let me know if you have any questions. If not, I'll come and I'll check on it in a bit. The P's are possible causes. The P is, could I just put pause for the spell? Possible causes. Raymond B. Is Raymond in this class? No, Raymond is in the process safety. As a student who got mixed up in the classes he's in. Exactly after you, right? Raymond is in another class. So I wouldn't admit him. I know you're not seeing what I see, but somebody trying to log in, right? All right, so possible causes of the increased temperature, and that could be anything. You can say possible causes could be, if you want to, I'll just call two for you. Possible causes could be human error. A worker, well, I'm just telling you this one, right? I'm not telling you to write this one, but you should write down like a possible cause is human error. Like somebody was supposed to lock off a valve now. They're supposed to lock it off like a gauger. So the temperature really go up and then this man get caught up in traffic, fall asleep or something and calling the other operator, phone and have no money, right? Maybe they sell services is done. So all of those are possible causes, right? Operator error, lack of communication, lack of clear standards, right? There are many possible causes. And if we talk about, what about power failure? So 5, right? So possible causes. So you cannot get that wrong. If they say, like outline each of the steps in a hazard, possible causes could be anything. Human error, manufacturer's defect, power failure, lack of clear reporting, no supervision, no training, the list goes. You don't need all of that for 4 marks. You just need to say about about one or two examples, right? Possible causes, the other word there, the C stands for consequences. And as you know, the consequences, somewhat we describe with the soft drink industry, could be product wastage. You can pick some easier consequence if you want. But I mean easier, you could just pick something like fire. Consequence of temperature increase is a fire. It results in a fire explosion. But what I'm trying to say, you can't just put the word consequence and you have to say consequences of uh, a deviation could result in fire, property damage, accident, injuries, death, right? And you can make up an example, say at a factory, if there is an increase in temperature and it results in a fire, this could be disastrous to the workers and to the population. And then you put your full stop. You make those 3 sentences out of it anyway. Consequences, right? Anybody could guess what the action is for? Or the A, I was saying crap, I was going to ask you and I ended up saying it, right? The A is actually action for improvement. I was going to ask you, although, see, silly. Right? Remember, this is a risk assessment, right? So remember, risk assessment is not meant just to say something is bad, but it's meant to prevent it. So the A is action for improvement. I'll say that again. Remember, risk assessment is not just to say the risk is 25. So it's not just to say the possible cause is human error. It's not just to say the consequences are fire. But the purpose of a risk assessment is really not to risk assess. The purpose of a risk assessment is not to risk assess. The purpose of a risk assessment is to produce controls to prevent the hazard from being realized. So the last thing here, the A is action. This is supposed to be 4. I think I was talking at the same time. This is FOR. Action 4. Look up at the number 4, right? But it's FOR, right? The A is action for improvement. Action for improvement. And that's it. right? The acronym, a lot of people remember it. Folks, I have people that come up to me. Well, if you wonder, well, remember oil and gas is new, but remember this is part of the degree too. Remember after level 5 is level 6, right? We teach HAZOP in the level 6 too. A lot of students love HAZOPs in the level 6. I've never come across a student that didn't like a HAZOP because it's an easy thing to remember now, right? So remember the acronym GDPCA. I was telling you what, I have people that come up to me some years afterwards and they say, sir, we still remember what GDPCA, but we can't remember what it stands for. But remember the acronym GDP. So what does that stand for again? It's been 5 years and I still remember GDPCA, but I don't know what it stands for, right? I get that all the time. People say, they remember this thing, GDPCA, but they don't remember what it stands for, right? But you don't remember for a long time. Remember just to get the exam. So can you tell me if you understand it a bit? You understand that these are the table headings. If we're looking at temperature and the team says more, they will look at what if the temperature goes up more than 20. I'll put 30 degrees Celsius here, right? I'll just repeat some of the things I said. They will ask themselves, what could be the possible causes of that? Human error, a lack of maintenance, a faulty valve, malicious destruction, somebody does do it on purpose. All of those things the team will consider. What is the consequence of the human error? It may result in a fire. It may result in product wastage. It may result in failure to deliver your goods on time to your client. And then how do we prevent that, the action to improve, right? So can you help me with that? With respect to the human error, how do you prevent human error? What like what's a way of preventing the operator from,
Training,
from making, say,
training.
training, right? So that's say it's not hard, training. So if they give you
Yeah.
one to do, you cannot say a HAZOP is hard because in a HAZOP, you're kind of free to do what you want. You just have to do it under the headings of GDPCE. But you can make up your own action. Training,
Yeah.
you can say supervision, you can say proper
Supervision. Yeah.
communication. Yeah. Yeah.
Mhm.
Right? So folks, you understand it? It is not rocket science. For now, you all go for an 8-mark question. And what I tell you, I don't see the asking you all of this for 8 marks. I can see 6. And then I can see the actual when to use a HAZOP, modification and design, right? So actually HAZOP is finished. Let me check with the chat and see what you all are saying. And HAZOP's actually finished, right? Well, for me, the hard part now for you to remember in GDPCA. And remember you have to pick what you're studying, and that's called a parameter. Some people put the parameter to the top here. Some people put it to the side. The parameter we have chosen is temperature. Whatever you choose to study, that's called a parameter, right? And then each one is on a line. I don't know if you know that. You can do more because remember it's a risk assessment, right? This would have been a column. Sorry, that would have been a row. This is a column. Each of these would have been separated. I have one on the slide, so I just really want to have on the slide, right? Each of that would have been separated. And if you want to do less, you can do less here. What if the temperature goes down? What if we take another guide would call other than? Other than means it have something else in your drink. If this was soft drink, it have something else in your drink. You say, what if a customer finds a fly in the drink? What if they find a knife in a bag of oats in Price Mart? What if? And what if that's actually a true one, right? So anyway, training and supervision, very good here. Amrish. Amrish also have risk by likelihood, right? Very good here. Okay. All right. Let me take all of that off. I have a visual of one. Trying to see, is it, well, I told you all, if more of you all had come by to collect your book, I would have made more reference to the textbook. I'm kind of using it. Once I know you have it, I'll use it, right? So you know, HAZOPs, page 25. They didn't do much. They have the same table, but they didn't give the format of it. They said same thing. If you feel I make up my notes, first used by the ICI in 1960. But do you know that my notes was written before the textbook? I think we all kind of research the same place, you see. Doesn't matter the book. It matters where the research came from. So if the book says ICI in 1960, I said the same thing, but I said it before it even had a textbook, right? All right. The book didn't seem to stress on the format of the table, right? Nor did they produce one for you. That doesn't mean, we teaching it, we can't produce one for you. They could have one here, right? This is well, in this case they didn't start a guide, but this like a company one. This is not a textbook one, this is one for a company. Deviation, causes, consequences. They actually worked out the risk here, and then they have safeguards. The safeguards would be the controls or the action for improvement. The next one in your book right there on page 25 is actually hazards. So if you want, we could go straight to hazards. Is not long, hazards is very short. If you watch your book, two paragraphs they have on it. We can go to hazards, and we could even touch FMEA too if you want. We could wrap up this here on page 125, right? For those who don't see what I'm seeing, that's what we see, right? That's a short paragraph on hazard. That's it right there. And the next thing is FMEA, right? The slides normally have more, but that's because we wanted to learn the thing and not just understand the thing, right? But not just to see it now, but to understand it, right? Let me tell you how easy a hazard is. I guess I'll read this slide and then I'll explain it, right? So a hazard study, which actually stands for hazard identification, right? Which is essentially a structured brainstorming technique, is carried out by a team of competent personnel from a mixture of discipline and led by a person who is experienced in the hazard technique. Just remember, this is not a hazard, right? Each area of the installation is considered against a checklist of hazards. Where it is agreed that the hazard exists in a particular area, the risk presented by that hazard is considered, and all possible means of either eliminating the hazard or controlling the risk and/or the necessity for further studies are noted in the hazard worksheet. Okay, I think I'll just explain it because all the rest is diagram, right? So the explanation is the second paragraph right here, right? So listen to it, right? A hazard is like a checklist that the company did. Like they went around already, right? And they had conditional valve, good, bad, fair, needs to be repaired, right? Temperature, too hot, just right, too cold, needs to be looked at, right? So in a hazard, what you're doing, you are just going with the prefabricated checklist. Watch it. Each area of the installation is considered against a checklist of hazards. So it's hazard identification. It finished already for you, but you are just going to verify that. You are going to see if the condition of the pipe is good, because they have a condition of the pipe and you have to select if it's good. Is it corroded? Does it have oil on it? Is it clean? So that's what you do. You are just identifying the hazards that are already on the hazard sheet. See if you understand that, right? So a team would have done the first study, watch it here, a team would have carried out a hazard study and then they would have documented what hazards are on the plan then. But when you go in to do it, you are not creating new hazards, but you are just looking at the hazards identifier and saying if the hazard exists or not, right? So when they say, where it is agreed that a hazard exists in a particular area, well, then they will do a risk assessment on that. So if they came back and they said, I realized like the valve for the tank was leaking, right? On the hazard sheet, it would have had conditional valve, good, bad, fair, right? But when you put bad and then you put the reason is a leak, well then that's a cause of concern. So they will start to risk assess that. And that's what they say here. Watch it again. The risk presented by the hazard is considered on all possible means of eliminating the hazard or controlling the risk and/or the necessity for further studies are noted in the hazard worksheet. So if this valve then cannot replace because it cannot find one, they might have to take a note, well, we might have to do a shutdown, or we may have to sort of close up this tank, close up maybe the manifold valve to this tank, because the valve have a leak and that's going to get into the water supply and get into the public, domain, and that's a different story. So they're documented on the hazard sheet, and we need to look at this and we need to kind of source another supplier, contact a contractor to have them, break out that line and repair it or whatever have you. But that goes in the hazard sheet. So you understand a hazard is not a hazard. In short, a hazard uses codes like the more and the less and stuff. But a hazard is like you are just going with a prefabricated sheet that a team would have done, as to what hazards are on the plant, and daily you are checking that out. Hence they say, for each area of the installation, it is considered against a checklist of hazards. Can't get easier than that, right? This is one way of thinking about it. This is something we got from one of our partner schools in the UK. And then this one shows a comparison between HAZIDs and HAZOPs. I can read it out for you then, right? So HAZIDs, systematic and structured review of health and safety risk from an operation, activity, or project utilizes a, what's that word here? Utilizes a what? What's the word? Utilizes. He has it, uses what type of approach? A
Checklist.
checklist approach. Very good, right? And it does actually include a risk assessment because once the hazard is identified, they do a risk assessment, right? Does not require process and instrumentation diagrams, or it may not require it. Well, you don't really require it because remember the hazards already listed for you. You just kind of looking to see, condition of this generator. They say noise, acceptable, too loud, seems to be, in need of repair. But you don't really need no diagram because you have a checklist, right? So if there's a steady level of noise, you might have a noise meter on you. If you have good, they may say 80 decibels. If you measure it fine and you get 80, fine. You say, okay. But you don't really need a diagram because the hazard noise is already there, right? With a hazard, we did mention is used at the design stage. They use guide words. Risks are not typically assessed. If we go back, I'll show you that. Watch it here. In a hazard, we didn't really assess the risk. We put guide words, deviation, possible cause, consequences, action. But we didn't really do no calculation. So in a hazard, the risk is not, assessed. And it may require what is called a P and ID diagram. People say it fast, so it sounds like P and ID. But process and instrumentation diagram. You may need a diagram to see like where, in a hazard, then like where is the acid going and mixing with the water. So you need to see that. But in the hazard, you don't need that because the hazard there for you. Do you have noise? Yes or no? That's how simple it is. I mean, it's more complicated than that, but that's the simplest way to say. Do you have noise? Right? Yes or no? And because you have a checklist, you don't really need any more diagrams anyway, right? Who knows? Folks, we try to share. I have a pass paper hiding somewhere. I think this window is in this piece of it. I'm trying to find it. See, almost 20 past 2 already. And I know it's how to teach. But it's best to look at one, right? I mean, it don't make sense to run down everything and then, we ignore question. Just let me know if you see there's something like a passive in the background here. Number 7. Can you all see it? No. Okay, good,
Yeah.
right? So, well, we can't do everything, but, I mean, it's not me to predict NEBOSH, right? But, we try, right? Answer number 7, we could come back to this next week, right? Watch it here. Concepts and commissioning process plan project phases where risk management applies. Identify 4 additional project phases where risk management applies. So that's not the technique. They're asking for 4 phases of a project. Concept and commissioning, but I don't think we come to that yet. You could probably just take one with design. Actually, it was on the slide. No, it was on my slide. What am I saying? It's on my slide. Could I read the question first and then I'll go back? It was on my slide. Modification, design. The verb identify means you don't have to explain. Identify just means identify. But you have to put it in a sentence. You have to say like, a further stage of a project plant may include modification, right? Operation, decommissioning. I don't think they said commissioning. What about decommissioning? But identify, folks, remember, like you don't have to explain if they say identify. Say, okay, just to say a stage would be decommissioning of product generator that has, got to the end of its life, right? Or catalyst that has gotten to the end of its life, if you know what that is. Or oil, if you just think of something simple, oil in your vehicle and stuff. Of course, I falsely believe that lasts forever anyway. But no, oil in the vehicle does have to change, right? So it reach the end point then. So then that's called, that could be said to be change out, right? Of course, if it's like the end of life of a product, which is the first example I used, it would be said to be decommissioning, right? But maintenance, right? Preventative maintenance is a stage of like a project as well, right? Anyway, outline the concept of ALARP. We haven't gotten to this. I mentioned that at the top of the hour. But for those who know it, it's very simple. I could actually tell you that it may ring a bell. It may ring a certificate bell, right? For those who know ALARP means you actually measure the level of risk against cost, time, and effort. And you're spending as much as you could spend to reduce the risk. That's why they say go as low. This is actually Wednesday class. As low as is reasonably practicable. It means spend the money. Spend it until it hurts your pocket then. Don't spend meagerly if the risk is high. Somebody getting into a vessel, hire an emergency crew, barrier, right? Contact the fire services, contact the ambulance services, maybe get a private ambulance out there. But spend the money as low as is reasonably practicable means you spend until it hurts you then, right? But you do as much as you could do to reduce the risk, the meaning of as low as is reasonably practicable, right? And the last one, part C, outline how a quantitative risk assessment may differ from a qualitative risk assessment. So when you see these things, remember the value of past papers. How does a quantitative risk assessment differ from a qualitative risk assessment? Think of two differences. You don't have to wait for the end of the course. You can do this now. I don't know if I think I'd sent you these papers. I can't be sure. If not, I could arrange to send it for you, right?
So that is on slide 48 in the handout that they gave us.
The same question?
Yeah, yeah.
Oh, look at that. I told you I wrote these slides in 2020, yeah? Anyway, let me go back and see. But we finished for today. I could probably just go to it and see. Look at the time. Right? Let me go down. So I guess we're not getting to do bow tie. You see, there's a thing, it's not a reading exercise. The most difficult thing with these courses is that, like the process, if we could read faster, because it's multiple choice, but here you have to slow down, right? Okay, so you want to give this a try as well? This will be your work for this week. The stages of the project phase was right on this slide. I just have to go back. I was actually matching it for you, and I match it again just now for you. Just to find the slide it was on. I'll probably pass it. Yeah, definitely pass it if I reach the
Slide
start.
21.
21, okay.
Slide 21.
Okay, slide 21. So you all take a note, look at there. Operation, review, construction. They just wanted 4. So then that means if something is the subject of a past paper, remember what the trick is with NEBOSH. NEBOSH have a trick or treat. Yeah, NEBOSH have a trick or treat. The trick is if you could figure them out, you get a question that you're already familiar with for exam. They have a high amount of repeats, right? But to me, even if it wasn't repeated, it kind of show you that the focus is on. Remember, I was focusing on how they matching up the techniques to the phase, but to the phases. But here we see a participle just asking you what are the phases, right? I was saying HAZOP for concept design and whatever, but they just asking the phases. So then try to learn 4. Some of them easy. Watch it. Commissioning, decommissioning. That's 2 one time, right? Construction. You can't forget that one. Modification. That's 4. I guess I'll have. There's no way I could start another one now, right? There's no way I can start another one, even though they're that simple. right? The end of this slide too, you see Wednesday, look ALARP right here, right? Where you balance cost, time, and effort. If you read this out, you'll see it, right? Hopefully you can see it somewhere here, right? As low as it's reasonably practicable means you're spending to reduce the risk. You're spending a good bit, but you're not spending all enough, right? But you're not going down to finish your pocket then. You're just making sure, okay, look, we had a budget for a rescue team, we had a budget for hiring a fire watch or some fire watch. You're spending there. You're going as low to, when I say hurt your pocket, I didn't say hurt you, hurt your pocket, right? Watch it. What they say, watch it here for me. As low as is reasonably practicable, seems to be what? It is seen to be a moderate cost. It's seen to be, that's what they say, reasonable, as low as is reasonable. It's kind of like you want to buy something for your loved one, and you have a choice. You see one for, I'm making up something, you see one for $300 and you see one for $250, right? So you could put the extra 15, 400 extra 100, right? So 450 then or 150, right? But you're not going to finish all the money you have in the bank because it'll be too expensive. But you are spending reasonably, but you're still going further than you'd normally go now. That's as low as is reasonably practicable, right? I was saying, watch this, right? You see here, this also have a question to this real simple enough. Documented evidence. Documents used in the oil and gas industry. Capacity per day, right? You know, one of the documents you could say is a HAZOP. You know, one of the documents you could say is which one again we do? The sorry, the HAZID. Those are documents. You don't have to wait till I reach it to get the documents in, right? Outline safety case documents, offshore and safety report documents, onshore contains similar information requirement. Identify these similar information requirement. One of them is what is the risk, right? I saw another passage, but just asking like to identify four like documents and use in the oil and gas industry. You already did something. Of course, it have more here, but you could say HAZOP. The fact that you learned something today, you can say it, right? And a HAZOP is just let's not forget what it is. It is a risk assessment. So if this is an advanced technique used in the oil and gas industry, what does it capture? It captures the risk, right? Okay, we have to stop, right? Because I actually have another class too. I'm gonna stop here. I didn't quite get where I wanted to, but that's because we stop and we